otherwise we're good. Okay. We've been working all week on what you guys have seen on the backboard, in that we were taking it section by section, the mock exam, at the same time as having you guys work on the additional practice exam, and then hopefully being able to ask some of those correction questions as well, because the ideal is by today or by Grace Monday. It would have been by Grace today too, but you know what I mean, as far as the Grace Day till Monday. Having the mock AP completely corrected, anything and everything you lost points on, figuring out how it could have been done. Maybe not should have been done by you personally, but could have been done. And then the additional practice AP fully attempted and graded, and my hope is corrected as well. But I won't be taking points off if you miss a correction here or there on the additional practice exam. So that's what we've been doing all week. Next week, what do we have? AP starting Monday. Now the nice thing is that's AP Chem, and none of you guys are in AP Chem because you're all in AP Calc. The afternoon is going to be AP Psych, and that could be some of you guys. But for the first exam in the morning, we're all going to still be in this class. We're going to all still be in this class. My sixth period and my fourth missing kids. And then you guys need to wait for AP schedule as far as like a day going to be gone, etc. But for us in here, we're preparing for a forever final. Sorry, wrong one. A forever final next Friday. The When You See You Think is due next Thursday. We'll go over questions to it on Thursday. Any of the bonus AP practice, what can you be doing for bonus points?
You can do all
All the evens of the LTFs, any evens that you did not do, or the optional practice exams. There are 3 posted optional practice exams, I believe. Is that right, Sarah? 3? 3 optional post practice exams. Remember, the one that you're doing right now, the additional, is required. That is a grade. It's due Monday in class, because I'm going to be, we'll talk about that in a second, I'll be grading it in class as you guys do something else. But the 3 optional practice exams are online, and then there's going to be a 4th, and that's the final, a 4th optional practice exam I'm going to email out. I'm hoping today. My life is a little crazy right now. But I'm going to hope to email that one out to you, and that one is going to be another, basically it's the mock AP from last year. So it's going to be of the new formatting, and it's the new formatting, the only thing that started last year was the questions that we're seeing in 2007 a little deeper, like that right Riemann sum that you had to take a limit to infinity. That one used the definition of an integral. It was a little bit deeper than old APs would have gone. Not that the work was impossible or hard, but it was deeper in the sense of, ooh, definition of an integral, limit to infinity. So 2017 started bringing in questions like that, or I should say, yeah, last year's AP to 2017. And then they brought in L'Hôpital's. L'Hôpital's was never on the AP AB exam before. That was the only new real concept that was included, and then the questions got a little different. So I'm going to email out, it's another secure exam, so I can't post it online. But I'm going to email a 4th optional exam that is the 2016 mock AP. So that would have been the one that the kids last year took for their Saturday exam. Sarah? Everything's due Monday. So not this Monday, but next Monday. Because I want all of it out of your life by that night so that you're not working on stressing for anything. And then after the AP, we're not, yeah. We're doing other stuff. So to that end, what are we doing next week? I told you guys Monday I need it ready in class for me to be able to check the corrections, update the scores of a couple of you that found little places that points were taken off that they shouldn't have been. Maybe you didn't erase your Scantron well enough. Maybe something on the FRQ, someone marked it wrong, that it shouldn't have been, etc. And I'll be grading your additional practice exams too. So while I'll be doing that, you guys are going to be working on, in a timed fashion, the FRQs from last year's actual AP exam. So that's what we're going to be doing in class. I'm going to have it printed off for you, none of this online stuff. And you will have 15 minutes to do FRQ1 with a calculator, 15 minutes to do FRQ2 with a calculator. We go over the questions to both. That's Monday. Tuesday, 3 and 4, we go over questions to both. That's Tuesday. Wednesday, 5 and 6. There we go. Mm-hmm. Right. All right. Sound good? Because before the AP, the best thing probably for us to do is FRQs, in that it really digs into the concepts, has us dig into the wording. And the FRQs, how did Mrs. Leon put it the other day? AFRQs, you are the master of your own fate and that you get to take what they give you and go with it and prove what you know and how well you know it, etc. So we need to make sure that some of you guys that got 0 out of 54, 3 out of 54, 8 out of 54, 12 out of 54 will have more points when you come to the actual AP, because there are 54 points to be had on that FRQ free response section. And not that you'll get all of them, and that's okay, but I want you to get as many as possible, because as you guys were looking at the AP scores, or the AP curving, I should say, between what made a 1, what made a 2, what made a 3, what made a 4, what made a 5, one FRQ can make all the difference. And I truly believe, just this is silly, but last year, my one kid in BC that did not get a 5 let me know about an FRQ that she didn't realize. She was like, oh, I didn't separate the variables. That's all that was. If she had gotten that one, I have full confidence she would have had 5. One FRQ. So some of you are like, well, I'm down in the 1 range. Well, it might be the difference between a 1 and a 3. Not a 1 and a 3, but it could be the difference because you were at a 1. I hope you're at a 2 now at least. But difference between a 2 and a 3, a 3 and a 4, a 4 and a 5. Those FRQ points are golden, but you have to work for them. So that's kind of where we're going, guys, for the next couple weeks. We have our job laid out for us today. HCTV is not playing today. Quick announcements. Ice pops, not ices. Anyway, things changed a little bit as far as what we're selling today during lunch, but we are selling cold things because it's going to be a hot day for $2. Missions come support. Tomorrow, pancake breakfast, rummage sale. There's a choir concert tonight at Shepherd. There's a band concert tomorrow here. Here, band people? Any? Okay. I think there's a band concert tomorrow here, which is after rummage sale, 3:30ish maybe. What else is going on? Track has some sort of Applebee's breakfast thing. I don't know if it's really been publicized, but there's a breakfast thing at Applebee's tomorrow. Sorry, we did not know that we were, but the rummage sale was already happening, so we just made ours. Lo siento. Wish I could come support, but I'll be a little elbows deep in pancake mix tomorrow. Random, your brother never answered if he could let you know what time he's thinking of helping tomorrow. Okay. Oh, sweet. We're going to be working starting at 6 and going until 1 to 2. So anytime you want to come. No, it's perfect. Perfect. That'd be awesome. Because Senior Brache is going to use help. You guys just know how crazy it was yesterday. Or were you there last year? I don't remember. How many does Miss Sutherland need? Okay, I'm going to give her my box and just say that I ask that they be protected and given back, okay? Most of those work. The TI graphing ones are the ones whose batteries are all dead. Problem is Miss Sutherland's students tend to destroy or lose or steal for calculators, so that's fun. Kiddos, I'm ready for whatever you have to throw at me. Okay, 5 what on 2013? C? Okay. Number 5, letter C. I'm getting my bearings really quickly on number 5. Ooh, geometry. Geometry. Anyway, with geometry, shouldn't we be thinking of area formulas somewhere? I see a triangle, a circle, a triangle. Anyway, that's just kind of random out there. What do I call, when you see you think, what do I call this type of problem, how you have a function equal from A to U? You might be using FTC part 2. It's not currently. There's no derivative. This is called the accumulator function. The accumulator function. Okay. Now, you guys can look at the answer key for the other ones. Letter A was strictly a geometry problem in the sense of g of x. You plug into the x bound, and this is defined to be finding the areas or accumulating the areas from -2. But in letter C, what's letter B asking? Oh, Tyler, here's your FTC part 2, because it says to find g prime of 0. To find g prime of 0, Zach, that's not how we work. Come on, bud. You need to stand up? Or are you doing okay? Doing okay? If you need to stand up, you can. Otherwise, just sit up. G prime of 0, we need to go ahead and take the derivative of g, and then the derivative of g, like Tyler was saying, gets us, I'm turning down the air so we can get it a little bit cooler in here. I apologize, it got warm. We can take the derivative of the integral, which gets us f of x. Anyway, but David's question was letter C. Letter C says find all values of x for which the graph of g has a horizontal tangent. Pause. Tell me the calculus behind that. G?
G prime equals 0, so therefore
Good.
f equals 0, so just take
Pause. So G prime needs to equal 0. As we just talked about, taking the derivative of G.
Who is G? You gotta FTC that puppy.
You gotta take the derivative of both sides. Yeah, because the derivative of G, G prime. The derivative of the integral, a to u, is f of u, and that's just f of x times x prime is 1. So this is the same thing as when f of x is 0. Kiddos, they gave us a graph of who? Who they give us a graph of? Uh-huh. So what they're asking is, when is f 0? Well, I see 1, 2, 3 places. -6, -2, and 2. It all came back to horizontal tangent, derivative equals 0. Go look at him and take the derivative of both sides and say, oh, there we go. And so you would have wanted to write that occurs at x equals, I think, -6, -2, and 2. Now hold on. Huh? Oh, thank you, the open interval. I wasn't even paying attention. They did want to steal a point from me. Now pause, that wasn't enough though, because it also says determine whether G has local maximum, minimum, or neither at each of the values. If I know that these are critical numbers or horizontal tangent lines, what do I need to have a max or min using the first derivative? I have to have the slope changing signs, the derivative changing signs, which on a graph can be seen by the y's, graph of a derivative, by the y's or the derivative values going from below to above or above to below. So, as you look at the graph, what's going on at -2? F, which is G prime, is going from above to above. Ah, so what sign does G prime have? Positive to positive. Is there any max or min if it's positive to positive? No. So we're going to say neither at -2, since G prime equals F goes from positive to positive, there is no sign change. But what's going on at 2? Above to below. So positive to negative, positive derivative to a negative derivative. Think about your sign chart. I apologize, I went too far. If you want, you could have thought of -6 to 3. You have your -2, you have your +2. Your G prime, which equals F, is going to go from above to below. If that helps you to actually draw it out. That's a neither. That's a maximum, but you must justify. So we're going to say that there is a local, use their wording, a local max at x equals 2. You guys, how would you finish that? What's the since? Because you have to write it out. That's not going to work. Yeah, since F, or you could say since G prime, which equals F, right, changes. Yeah, not just sign, from positive to negative at that point.
How do you put like a tangent, like a vertical tangent line in G of x?
I'll get back to that when I finish the problem. And neither at x equals -2, since you can say has no sign change. There is no sign change. You can say it goes from positive to positive. A few different ways of writing it. But long story short, you had to establish G prime, which is F. You're looking at his signs. At 2, that quantity goes from positive to negative, and at -2, there is no sign change. Okay? Now, Charlotte asked the question, wait a minute, hold on, for relative mins and maxes, you can technically look at horizontal tangent lines or vertical tangent lines, zeros or DNEs. Now, they only said horizontal, so that's all I was looking for. But she was like, how on earth would you see a vertical tangent line on a graph of a derivative? Well, it wouldn't be a 0, because those are horizontal tangent lines. What would it look like? Not sure. Doesn't exist, which would be the second derivative of G. It would look like this. A vertical asymptote. If I was allowed to keep going at -8, according to this graph, how I made it, at -8, there would be a relative minimum. Because as long as my original quantity g is continuous, then I know that this vertical asymptote was not there to begin with. It must have come from a vertical tangent line. And if you look below to above, negative derivative to positive derivative, there's a relative min at this vertical. Actually, this wouldn't be a vertical tangent line. This would be a sharp point. This would be a sharp point. Why min? Because below to above. My sign chart, if I was to keep going, at -8, we'll go from below to above. So this is a D and E. These are zeros. That's a neither, that's a neither, that's a relative max. This would be a relative min because below to above, negative to positive. This would be like a D and E. So those are zeros, those are D and E. That would technically be a sharp point. It would be one of these ones, like a cusp. Because then those are all positive, those are all negative. Yeah, it'd be like one of these ones. Awesome. Yeah. Well, it's kind of, you have to think back to algebra, plugging in first of all. So for letter A, just think g of x, right? So you need to plug into the x spot, and the x spot is right there. So then you would go from -2 to -6 for g of -6. Does that make sense? You're just plugging in. And then you'd have your f of t dt. I don't know exactly what forever card. It might kind of go under the area card with the rectangles and the trapezoids, sort of. But an integral, how do I solve it if I don't have a function? I say, uh-oh, I hope I can find the area. And so the area from -2 to -6, and here's a little bit of a struggle. It's going backwards. Since it's going backwards, you can think of it as the opposite of going forwards. But all you have to do is say area of a triangle. 1, 2, 3, 4. The base is 4, and the height is 5. So I'm going to have -1/2 base times height. And you wouldn't simplify. Does that make sense? Because it's a triangle. So 1/2 base times height. So I did the base, I did the height, times 1/2. And it's going to be, isn't it 4 and 5? 4 and 5. It's negative because you're going backwards. You have to switch the bounds. That's where the negative comes in. So in Austin, how would you do g of 3? Good. And since you're going from -2 to 3, that's like a normal direction, right? Good. So how are you going to think about that then? Good. Semicircle, which has an area formula of?
1/2 pi r squared.
Okay, so I'm going to do 1/2 pi. Well, I guess I could have just written the pi. Who's your r of that circle?
2.
Good. Good. And what am I going to do when I come over here? Because I have to keep going, right? Add?
Well, you can add, but
Add the negative or subtract because it's below. As we came, because this is just -2 to 2, I need to go to 3. To go from 2 to 3, I need the triangle, but it's below, so I need to subtract the positive area. And the area of a triangle is 1/2 base times height, right? So I have a base of 1 and a height of 2. So I'm going to have, we're not simplifying. Don't let them take away those points. Yeah. Yes.
specifically points I have those, but
Okay, looking at letter D.
the justification.
Ooh, I love it. I love it. Okay. You have a graph. Remember? G. There is hope. You just have to give your brain a chance to internalize it and practice it. Pause. We've already talked about this guy, accumulator. We're finding areas to find him, right? We've talked about this guy, the second fundamental theorem of calculus. Derivative of an integral is f of u times u prime. Now I need to look at this guy, points of inflection. How do I find the second derivative? I take the derivative. So who's the derivative? F prime of x. G double prime, right? Take the derivative of both sides. Take the derivative of both sides. This makes sense, right? G, point of inflection, I need G double prime. To find G double prime, I need to take the derivative of both sides. The derivative of G prime, G double prime. The derivative of F, F prime. Now I have a graph of F. If I need to think about F prime, how do I think of derivatives given the original? How do I think of derivatives given the graph of the original? Slopes of F. So to think about the second derivative of G, I need to think about the slopes of F. You guys have the graph, right? In order to have a point of inflection, use your forever card. Points of inflection occur when actual inflection points, points of inflection, not possible. They occur when what? Good, G. When G double prime of X, which equals F prime of X, changes. What has to happen for there to be a point of inflection? I need the second derivative to change signs. Changes signs at zeros or DNEs of G double prime. This occurs at, have I even thought about my graph yet? Nope, I've just stated a forever card. Now I just need to tie it all together. So points of inflection occur when the second derivative, who's that guy in this context, changes signs at zeros or DNEs of the second derivative. This occurs at or when, look at your graph. Where will the slopes change signs, or where will F change from increasing to decreasing or decreasing to increasing? At relative maxes or mins. So where are the relative maxes or mins of that number 5 if you look at his graph? Oh, careful, I heard 2 different ones. The slopes change signs at -4, see it? At -2, good, and 0, and that's it. So I need F, which is G prime, to change from increasing to decreasing, or you can think the slopes to change signs, which will occur at -4, at -2, and at 0. Yes, as long as you say F changes from increasing to decreasing, or vice versa. You have to do, because it does both. Good, good. But you have to say F, not F prime. Yeah. Yeah. Good. Yes, because FTC part 2 says anytime you take the derivative of an integral from a to u of f of t dt, you will end up with f of u. The integral leaves.
So for this graph, f of u would be 2 times f of u prime.
This one's -2 to x.
Okay.
So I just plug in x, and x prime is just 1. Because the derivative of x.
I was asking for g prime of 0. I don't get like what you have to do.
Oh, well, we have to, first we find g. G prime of x says take the derivative of this guy. To take the derivative of this guy, we can use our formula. So we would get f of x times 1, which is just f of x. But now, of 0, don't you have to plug in? Now I say, who's f? Oh, look at the graph. F of 0. What is the y at 0? And the y at 0 is... But do you see it? Get a colored pen. You got to mark it. Your brain's not going to just naturally remember. Just because it makes sense today doesn't mean it sticks. But it's not as hard as you think. Charlotte, where do you want me to go? Okay, number 2, 2017. C. Okay. Let me take a picture. Yeah, this one was actually quite clever. This one is a great problem, but it's challenging. Okay? For some of you, to be honest, this part C should probably just kind of be a wash for you. Like, at this point, it's probably not a great idea if you don't kind of get it already. You might just want to be like, you know what, I'll just lose the points on this one. But for the rest of you, let me go ahead and talk it out real fast. I'm going to grab my calculator out. Ideally, in this, if I can find it, lo siento. Struggle. There we go. Okay, in this function, ideally you already have in your calculator a few things, and you've already found a few things. They told us that this portion of b of t right here is, help me out real quick, this portion is going to be 20.5, right? Y equals, or b of t equals. This is for my b of t is equal to 20.5 for t within 0 to, was that k? Is that what they called that? Shush! 0 to k. 20.5. Then all of a sudden, this starts to curve. This cannot be a line past this point. So 20.5 only works for right here. In this problem, they're saying the area of the region bounded by the graphs of A and B is 14.47. So they also additionally just told us that this area right here is 14.470. How much water is in the tank at t equals 2.416? Now, this one, W sub B is how I made up a variable W. I have 2.416. This is integration as net change, WB of 0 plus the integral from 0 to 2.416 of, I need my B of t dt. Now here's the struggle. I don't have an equation for B of t dt. Now, I do know W of B is 0 according to the problem. Both tanks start empty. And I know that B of t is equal to 20.5 for part of this, from 0 to k, which I think, did I call this the intersection point AB? No. I'll just put 0 to k. 0 to k, I know that B of t is 20.5, so I can do that. But the problem is I also need from k to 2.416. Well, how on earth am I supposed to get that? Because I need, right here, I need this guy. I need that guy. If I could get this, I could plug into, wait. This and that make what?
A of t.
The integral of A of t. I have an equation for A of t. So I can take, for this little piece, because I don't know B of t past 20.5, past k, but I do know, or I could find, that integral from k to 2.416 of A of t. I have that guy, and I could subtract, take the area under A, and subtract 14.470. Now all of a sudden, I've got it and I'm good to go. Does that make sense? Yeah. So it was impossible unless you realize, wait, the whole thing is under A. I know 14.47 I can solve for, and now I can finish my problem. Okay, Sean. Oh, Charlotte.
For the equation that, they say the constant of it is 20.5.
But if you look in letter B, that's only for a certain interval. It just says, because it's not a line,
But is that mean
just here.
so y should be equal to 20?
B of t equals 20.5.
The equation should be like y equal 20.5.
Well, here's what I showed here. Oh, no, I erased it, didn't I? Oh, it's on here. B of t is a piecewise function. So B of t equals 20.5 for this part, and it equals something different for everything else. So 20.5 is B of t for a little while, and then B of t changes to something else.
And that constant means that you don't have variable.
Right. That's why I just put in 20.5 to my integral for B of t. But that only works from 0 to k. Doesn't work past k. And also d. So then using the same information, or the same graph at least, during the time interval 2.7 to 4.5, I have W of t. Oh, that's my B of t? The water flows into tank B, modeled by, can I just clear all this? Nope, I can't clear all this. Okay, that's annoying. Okay. 2.7 to 4.5. The rate at which the water flows into is modeled by W of t. Is the difference W of t minus A of t increasing or decreasing at time? Well, wait a minute. Hold on. It says at time, right? So can't I difference? That just means subtraction. W of 3.5 minus A of 3.5. I have this equation, plug in my calculator. I have this equation, plug in my calculator from above. Increasing or decreasing. Oh, wait. Increasing or decreasing, it's not asking me to subtract those. Increasing or decreasing, it's asking me to look at their rates. It's asking me to look at their rates. Is the difference W of t minus A of t increasing or decreasing at time t equals 3.5? So therefore, you could think of basically the derivative. And the derivative will be, since they're separate like that, just W prime of t minus A prime of t. But you're going to be plugging in such that t equals 3.5. So you're kind of looking at, if you want to think about it, difference prime. So W prime minus A prime, plug in 3.5 and ask yourself, okay, is it positive? Cool, increasing. Is it negative? Okay, cool, decreasing. Done. Yeah. Tyler, go ahead.
Don't go there. 5A.
2013?
Yes,
Okay. Sean, what was your question?
I actually figured
Did I just, was the dx the only thing that's not right about that? Or is that why I didn't get that point?
You got a +1, right? Do not evaluate. Your e to the x is on top, your square root of cosine. X is on the bottom. Your 0 to pi over 2. Yeah. Should have been a check with the cross. Los Santo, Noah's writing wasn't so good. What else? Any other FRQs? Yeah, Sam. 3A on 13? 17. Okay, we're looking at 3A. Hey, kiddos who were just asking about the 2013, you got really frustrated about it, here's your chance. Okay, let's try this again. But this is a little different question, but do you see your accumulator? I see him. It's okay. It's okay. Forever card. Sam, forever card. Find the average rate of change of G from -5 to 5. Don't even worry about everything else. Just think forever card. Average rate of change. How do we do that? Yes, except of G. So G of... Good. Okay. Okay. Ready? Don't I need to plug in to G? There's my G. He's right there. Don't even plug into G. So I'm going to say, okay, the average rate of change is equal to, well, G of 5, wouldn't that be the integral from 1 to 5 of f of t dt? Minus, okay, what am I going to plug in for G of -5? From 1 to -5 of f of t dt all over 10. Or you could do 5 minus -5 because you're paranoid. Okay. That's fine. How do I find an integral of a graph that's been given to me? Area. Area. So, from 1 to 5. Here's my 1, 2, 3, 4, 5. There's my 5. I see, just, this is me because I'm lazy. I see a triangle and a rectangle. And I'm moving the positive or the normal direction from left to right. So cool, let's just keep it how it is. It's above, it's going to be a positive number, the area. I have a base of 2. I have a height of 1, 2, 3, 4. So this one's going to be 1/2 base height minus. Okay, 1 to 5. 1/2 base times height. Sure. Wait, but what am I missing? Base times height. Don't I need to also do a plus? Okay, so I needed my 1/2 base times height, and I needed my base times height. So I did my 1/2 2 times 4, and I did my 2 times 4. Rectangle, triangle, there it is. Minus. Now what is it time to do? That guy is a check. Yep. From 1 to -5. Ew, I'm going backwards. So you could pull out the negative if you would like. You could make this a positive, the integral from -5 to 1. Bounds. If you have an integral b to a, we always do a to b. We don't do b to a. If you have an integral b to a, it's the same thing as opposite going the normal way. Area is, but if you have area below, we call it negative displacement, or area above is positive displacement. But if you're going backwards, you have to also think of a negative. So think of it this way. Backwards and below, a negative negative is going to make a positive. If it was just backward, if I was going backwards here, this would be a negative area. If I'm going backwards here, it's going to be a positive area. If I'm going forwards, a negative area. And if I'm going forwards, a positive area. Okay, hold on. Give me a second. You see the triangle?
Yeah, I see that.
Okay, so that's going to be 1/2 base times height, so that's 1/2, 1 times 2. 1/2, but I'm adding, right? Hold on, a negative negative makes a positive, right? 1/2 base times height plus, isn't that a quarter circle? Because check it, 2 and 2, that's a radii. So it's going to be 1/4 pi 2 squared. I'm not done. Now I have a triangle, and I have a base of 3 and a height of 4. So 1/2, 3 times 4. Well, because I'm going backwards, the negative negative. Now pause. You're going to miss all these points unless you take this whole thing and put it over what? You won't miss all the points, but you will miss some. Put it over 5 minus negative 5. Sure. I'm just paranoid because I've had to mark off too many stupid math mistakes. Charlotte.
When I'm doing the average value of...
Nope, it says average rate.
No, I'm doing the average value of f. Can I do that?
Yeah, you could do that.
But they take...
It'd be the same thing though. Because the average value would be 1/10 times the integral from -5 to 5 of f. Same thing. Oh, we should have done f of t. Something went wrong here. So that what? Highlight it, and then write me a note on here, because I can look at it when I look at yours. You should get the integral. You should get that point. I don't know if your answer matches up or not. I have to check it. All right, another question, David. Well, I'll do B. I'll check for any other questions. Let's do B. Instantaneous rate of change. Same thing as the derivative of who? G prime of 3 is what I want, so think of G prime of x. Kiddos, look at the, no pause, look at the equation. Take the derivative of both sides. The derivative of G is G prime. The derivative of the integral, the accumulator. No. The derivative of G is G prime. The derivative of the integral, FTC part 2, f of x. Remember, like Sarah was saying, the derivative of the integral, think of the integral kind of disappearing, f of u times u prime. So when I need 3, G prime of 3 equals f of 3. Sarah, what are we going to do to find him? Go to the function, go to the graph, and look at the y value.
Can we see the graph?
Sure. 1, 2, 3, 1, 2, 3, 4. It's 4. Yeah, Tyler.
It's not on the board either.
Like it's not on either FRQ?
No, it is.
It is on an FRQ? So you're being selfish and coming up?
Yes.
Yes. Pause. Make sure you put the square in the right spot, but I think it's in the right spot. Charlotte.
Next one,
4 on this one. Number 4B. Okay, 4 gives us a table. All right. This one was funny. The key, the key for letter B was this right here. I have a table of all these different f primes, but this fact tells me that f prime will never go above 7. So then down here when it says determine whether the actual value of 6, okay, hold on, the actual value of 6, I would need to think of some sort of initial, oh, hey, they do give me f of 0, so I'll start there. Plus the integral from 0 to 6 of f prime of x dx. I don't know the integral. I can't solve the integral, but I do know a table of values. I could do Riemann sums. But here's the dealio that said, could it actually reach 70? Well, I need to think of, I know this is 20. And then I know that f prime is bounded by 7. So the maximum that f prime can be is 7. So if I have f prime doing all this like blah, 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 the maximum it can be is 7. So here's the dealio, and that's 6. I can do a rectangle to find an over approximate. And I can say, okay, if I multiply 6 times 7, the most, which is, it's more because it's sometimes down, the most this can be is 40. Say 42 plus 20. F of 6 has to be less than that. Haha, 62. It cannot be 70. All right, bye, guys. I'll do more questions in period 6. If yours weren't answered, check out their video. Bye, guys. Happy Friday.